Right. Our starting point today is going to be on the higher order Taylor method. We call it higher order because we choose the order in the question. So the question states the order. So now, but first things first, we recap on the formula that we stated last time, but I stated that one at the end. And it is nothing other than the Taylor method. Right, so the Taylor method of order n. Okay, I want us to solve some exercises on this. Several exercises. Just to create that level of confidence, but also to be in a position to compare this method to the Euler and others. Right, but what is the formula for the Taylor method that is the general formula for any given problem on the Taylor method? Right, first we consider the initial condition because these are initial value problems. Then we have the difference equation associated with the Taylor method, which is Wi plus 1, Wi plus ht to the power n into t sub I wi. And this is true for each I 0, 1 up to n minus 1, where we state that our t sub n, or t rather superscript n, which is the nth derivative of ti wi. Okay, this is the formula we stated. It's very important. We pay particular attention to the higher order derivative of the differential equation, which is obviously stated as this. Then you have t sub I w sub I plus h over 2. Okay, I'm going to state a bit more terms than we did last time when we discussed this method. And then let me just state one more term here. Right, so we state the terms, but we realize that if this one is the first derivative, then it is the same. There's the power of the h. So in other words, if now we move on and we state h squared, that is going to be the second derivative of t sub I wi, like so. And the question is, what divides here? What divides here is nothing other than the n. Okay, I'm going to explain what I mean by the n. There's an n that comes in here. Okay, I studied last time. So you have h to the power n minus 1, f n minus 1, t sub I wi. We divide everything by n factorial. Okay, so if then we have h squared here, this is going to be exactly 3 factorial. Okay, and then and so on and so forth. But it can be written as 6 as well. But the factorial notation is more standard. So going with the factorial notation, you can even put 2 factorial here, which is just 2 anyway. Okay, right. And moreover, we reinforce the relation between the former method we studied before. We just use this to solve a couple of exercises from the prescribed textbook. Right, so now Euler's method is is Taylor. I'm mentioning Euler's method because that's what we did last time. But yeah, I'm going to highlight Taylor's method again, the modified Taylor and so on today. Right, so Euler's method is Taylor's method of order 1. Right, Taylor's method of order 1. Right, from tomorrow I'm going to cite we'll be in a position to cite the exam questions that appeared in November in relation to the things we are discussing today. Okay, let's look at some problems that involve these, because we just studied the formula here, but what are the examples that are involved here? Let's get to take a look. Example 1. Right, so we're looking at example 1. What is example 1? So we shall just apply these in 2 cases. There's a case I looked at last time, but I'm going to recap on that because we shall be extending or studying an extension of what we did, what we did at the end of last time's discussion. Like if we say apply Taylor's method. Right, so this is example 1. Right, so but now here we're going to apply Taylor's method of orders. Of orders A2. And B4. Okay, we did order 2 last time with n equals 10 to the initial value. Right, to the initial value problem. Right, the initial value problem is the first derivative of y with respect to t is y minus t squared plus 1. Okay, you shall be studying this problem a little bit more in detail. Different orders 2 and 4. We did order 2 last time, I agree, but there's a recap and there's a comment I want to make of something that was overlooked in our previous discussion. So y0, 0.5, and you can use any of the methods, yeah, doesn't matter. So yeah, we use a variation of the methods. Right, let's look at the solution to this. Right, so what is the solution to this? Right, first, obviously, we shall look at A part. Right, so obviously we're speaking of order 2. For the Taylor's method of order 2, what do we need? We need, okay, this came in the exam in November, Taylor, but yeah, we shall be extending these to other Runge-Kutta and so on. We need,
Hello?
yes, please.
I think we did this last time.
Yeah, we did order 2. But I want to mention order 4 today. Right, but I'm just going to highlight in passing order 2, just a statement. And I'll then begin doing order 4. Okay, yeah, you're right. We did order 2, but I'm just going to highlight the statement and move quickly to the 4th order. Right, because I started this exercise, but we did not do part B. And part B is actually what highlights order 4. We did order 2. But I'm just going to state order 2 so that one can just be in a position to sort of understand how we just go through the orders. For instance, the Taylor's method of order 2, we need the first derivative. Right, the first derivative. Right, the first derivative of. Okay, I'm just going to do the derivative. Right, obviously the first derivative of the function. What is the function? It's the given one, so which is exactly f of t and yt. And this, the f is the first derivative, which is y minus, can call it y of t, minus t squared plus 1. Okay, that is exactly the function f. Right, so if we find the first derivative, then we have f primed of t, y of t. So in other words, if we find the derivative of this, we'll just recap on that because we shall do higher order today. And then we have the derivative of the right-hand side, which is y minus t squared plus 1, which is y primed minus twice t. And then what is y primed? Y primed is this. Y primed is actually y of t minus t squared plus 1, but minus twice t. So we just substitute the y primed there. And then obviously, I want to just highlight the formulas that we use. Okay, we did exactly that. Okay, we're looking at part B now. Right, for order 4, or the fourth order. Right, let's highlight what is gonna happen here. Okay, let's we did not solve this one. We shall start by stating the formula, but the question is, what do we need? We need the third derivative, and we shall see why. So we need the third derivative. And once again, we shall see why we need the third derivative here. So we just need one less. Right, so order 4, we need the third derivative. But why the third if it's order 4? Okay, it's just a formula there. So we shall see what is the case here. Right. Okay, order 4. Okay, let me first look at this. Okay, so if it's order 4, then it means that we shall have, let's just write properly. We can just write like this and then just compute. So it makes things easier to always follow. So if you write the general formula and then be in a position to apply that. So in other words, we shall say W0 is alpha. Then we write the general formula for the Taylor, the nth order. So it's Wi plus 1, which is Wi plus ht to the power n of ti wi. Right, for each I, 0, 1, and so on, n minus 1. Now, so in other words, n is 4 for order 4. So if n is 4, what does it mean for us? Right. Well, it means that we shall have W0 alpha, and then we'll have Wi plus 1, which is Wi plus ht of 4 for the derivative. Then we have ti wi. Okay, and then once we write this, then we are done with the problem. It remains to just look at the difference equation, just get the difference equation in a more explicit manner. But the question is, what is T4? Because now we have Tn here. This is Tn, the nth derivative of T. But what will T4 be? Where is it going to stop? Right, because this is, if it's n here, then it stops at n minus 1, meaning it stops at 3. Right, so it helps to always write down the general formula than to just write a specific formula. So we're going to write first the general formula and say Tn. Ti, then we can get the specific one from it, which is F, which is what I'm trying to cultivate here, as we shall be applying these to last year's October exam. All right, so we have F prime to Ti, Wi, and then plus dot dot dot, yeah, and then we have Hn minus 1 divided by n factorial, right, the nth minus 1 derivative of f, then Ti, then Wi. Right, meaning that n is 4 this time around for the fourth order, and that means we have fourth derivative of the Ti. Then we have this, so which means we shall have Ti Wi plus, then we have h over 2. Okay, because once we write this once, then we shall do the rest of the estimations. We just need to get the difference equation more explicitly. And then we have here f primed of Ti Wi plus, okay, because it's T4, then we're going to stop when we reach 4 minus 1, because n minus 1, we're going to stop at 3. Okay, let's get to 2 now, the second derivative, but obviously the power here is always the same as the power there. So which means that for the second derivative, it's going to be h squared f double prime like this, and it is divided by what? It's divided by, now because is always divided by 1 more than this. So it's going to be 3. We saw that. Okay, let me write things properly here. Okay, the 3, let's just write the 3 below the h. Right, meaning you have here the 3, but now it's a factorial. Okay, because it's always the factorial there. And then you have Ti, then Wi. Okay, then we add to it the next one. Maybe we can squeeze it here. Okay, there's no space there, so that it all fits in one line. And now let's write that one out. Right, which means therefore you have h. Right, so if you have h here, so it's going to be h cubed. Okay, and then if it's cubed, then this one is 1 more, so it's going to be like 4 factorial. And then it is f 2, 2, 1, 1, so it's going to be 3, 3, and then Ti Wi, like so. Okay, so this formula is therefore complete. But what is then the meaning of these? So we need different f's here. Okay, let's start with the given one. So which means now we have the f, which is the first derivative, which is exactly that one, right? Which is exactly that one. So I'm going to write that one down and then compute the rest of the derivatives so that we can plug the first, right? So, but we know that f Ti Wi, like so, is y primed, which is exactly y minus t squared plus 1. Then now we're going to do the first primed. So we differentiate this one. And then we have this Wi. Okay, if you differentiate this one, we've seen that it is dt of this, which is y minus t squared plus 1, which is y primed minus 2t. Okay, what is y primed? It is exactly y minus t squared plus 1. Let's get them out, these derivatives. Then now, okay, we needed the first one, then we need also the second one. So we're going to do the second derivative, which is TI WI, which is d dt of the following. Right, so d dt of what? Of this one. So it's going to be d dt of, okay, so this one is minus 2t here. Put this minus 2t and the y prime is this, and then it's minus 2t. Okay, now we need to obviously differentiate the previous one. So we're going to find the derivative of y minus t squared plus 1 minus twice t. Okay, so we find the derivative of this. Right, which means the derivative of this one is going to be exactly y primed minus twice t. And then the derivative of this one is going to be 0 because it's 1 is a constant, and then minus 2. And then y primed means what? Means exactly what we need to get. What is y primed? It's exactly this here, which is exactly y minus t squared plus 1 minus 2t minus 2, like this. And what is this? This is y minus t squared minus 2t minus 1. And this is f double prime of ti wi. Okay. Now we just need the last one to compute the third derivative. Sorry. Now we continue to do that part. Sorry. Now we want the third derivative of ti wi. How do we get it? We get it by doing the derivative of the second one. Well, yeah, differentiating the this function, and then now we have d dt of this one. What is the f double primed? Let's check. F double primed is exactly y minus t squared minus 2t minus 1. So it's y minus t squared minus 2t minus 1. Okay, like so. Right, so now obviously we're getting the third one. And let's get the third one and see what that one is gonna hold for us in store. Okay, let's see now. This one is gonna be y primed minus twice t minus 2. Right, like so. And then we just need to plug in the y primed. Okay, we already know y primed off by heart at the moment. Y primed is the given one, which is y minus t squared plus 1 minus 2t minus 2. And this, we just need to add like terms together, which is y minus t squared minus 2t minus 1. So it is f double prime. So ti wi. Okay, so this is what we get. All right, so now, but what have we got? So this one is exactly the third derivative. And so what is the meaning of all these right now? So we need to get the Taylor polynomial after this. Right, hence we have T4 of TIWI, which is exactly f of TIWI plus h over 2 f primed of TIWI plus h squared over 3 factorial was 6 f double primed of TIWI plus h cubed over 4 factorial f 1, 2, 3 of TIWI, like so. Okay, and then now let's just do the substitution of everything and see what we get. So this is going to be T4. Right, let me do it on the next slide because it's going to be too many things a little bit. So see what you're going to have here. Yeah, I need to turn to the next slide because I need to simplify these. Right, let's just continue on the next slide. So T4 TIWI. So this one is going to be exactly T4 TIWI. Okay, because this Taylor is what breeds the other higher order, things like your Runge-Kutta and others and your modified Euler. So now we have this. Having this now, we must put the original one from the examiner. So what is the original one? But we just change the Y to the W and the T, we make it TI. Everything has II. So it's subscripts. So this one is going to be WI minus TI squared plus 1. There's plus, and then there's H over 2 into the first derivative. And what is the first derivative? Okay, the first derivative is WI minus TI squared plus 1 minus 2 TI. Okay, so we have this one is going to be the third one. Second, if it's 2 here, it becomes 3 factorial. As much as this one is 2 factorial, which is just 2 always. So what is the this is the first and this is the second derivative. What is the second derivative? We got it. It is WI minus TI squared minus 2TI minus 1 plus, and then we have H cubed divided by 4 factorial. So there is one more. If it's 3 here, it's plus 1. 3 plus 1, it is 4. And then here, this one is WI minus TI squared minus twice T minus 1. Okay, so now we've substituted the F primed, the F double primed, the triple primed. Okay, so we've got that. But what does this simplify to? Let's just simplify this. TIWI. Let's just simplify these. Group like terms together and so on and so forth. Right. So if we group like terms together, what this becomes is, you can leave it like this, but grouping like terms makes it easier to have one difference equation that you're going to substitute into the difference equation associated with the Taylor. So it's 1 plus grouping everything is H over 2 plus H squared over 6, and then plus H cubed over 24. And then minus TI squared minus 1 plus H over 3 plus H squared over 12. And then this is exactly H TI. Okay, you can write like that, you can leave this out. And then we have plus 1 plus H over 2 minus H squared over 6 minus H cubed over 24. This is minus H cubed over 24 minus H squared over 6, which is 3 factorial. And then there's H over 2, which is going to come from here. And then we have the 1. Then you have the WI and the T squared. All of them, we just grouped them like that. So it's just one way of grouping the things up there. And what is then the meaning of all these here? Hence, Hence, Taylor's method of order 4 is, okay, what is Taylor's method of order 4? Okay, let's write it down. So it's going to be W0, which is alpha 0.5 for the question. We can refer to it. And then now we're going to have the difference equation. So the difference equation is Wi, which is okay, is Wi plus 1, which is this. So Wi plus 1 is Wi h into the t to the n. So that's what we're going to use. So Wi plus 1 is Wi plus h into the t. What is the t? 1 plus h over 2 plus h squared over 6 plus h cubed over 24. You close like this. We have Wi minus ti squared minus, like this, 1 plus h over 3 plus h squared over 12 hti plus 1 plus h over 2 minus h squared over 6 minus h cubed over 24. Like so. Okay. So you have plugged in the t to the 4th power there for the 4th order. And this is the difference equation, and this is the initial condition. So everything is actually, everything has brought us this far. And this is what we're going to use to further get the rest of this. So this is true for I equals 0, 1, until n minus 1. Because if you look at the question, this question says, yeah, okay, apply Taylor's method of order 4 with n equals to 10. T lies between 0 and 2. If t lies between 0 and 2, we want to divide this interval into 10 parts. So this is how we do it. Right, so because n equals 10, t in the question lies between 0 and 2. This implies that h, now we need to find h. So if you divide this one into 10 parts, how do we divide this into 10 parts? So it's going to be 2 minus 0 out of 10. 1 out of 5, because 2 goes 5 times into that, which is 0.2. And h now we calculated to be 0.2 because they just told us n equals 10. They did not give us the h there. The method becomes, right, so the method then becomes the following. It becomes Wi plus 1, which is Wi. So it's exactly this, but now we're just plugging in the h. So which means that, yeah, plus, so this is going to be 0.2. If we put the h 0.2 there, 1 plus 0.2 out of 2, which is 0.2 out of 2 plus, okay, 0.2 squared is 0.04 out of 6 plus, if you cube it, 0.2 cubed is 0.08. 0.008 out of 24. Okay, and then we have here Wi minus this one. You can do it in 2 ways. You can just keep it STI. I like it. I like keeping it STI. It's popular. But you can also use the method of you can also use TI equals 0.2i. So because TI, because the H is this, you can just say TI becomes 0.2 because everything moves in 0.2, and then you multiply by 2 because multiply by I because it's 0.2 plus 0.2 plus 0.2. So it's like multiplying by a number in integer each time you move to the next step. So in which case, therefore, that I feel that it's common to just leave it in terms of T. Then minus into, let me write it at the bottom. Right, so this is going to be minus here, minus. So, right, this one is going to be minus over here. So it's going to be 1 plus 0.2 out of 3 plus, okay, 0.2 you square it is 0.04 out of 12. Okay. And then it is, now you come here. What is this exactly? So H is 0.2, but is multiplied by TI. Plus, so now we're here. So it's plus 1 plus, so this one here is 0.2 out of 2. We're just doing the 4th order today, and then we move on from the Taylor, but we shall do a textbook exercise, etc., from the ones I highlighted last time. So 0.2 squared is 0.04. That's 0.2 squared out of 6. Then we have minus 0.08 out of 24. Right, so it's when you cube everything, and then you close like this. Okay, so that's what we get. So now we just need to, because these things are numbers, these, so we can just add everything here, multiply by this, and then get the next step. Let's see what we're gonna, yeah, this plus this plus this, multiply by 0.2. We add all these, multiply by 0, and so on. Okay, let's move to the next. So this means, therefore, we get Wi plus 1. Okay, if you do everything right, what do we get here for the Wi? It's going to be 1.2214 Wi. And then now you have everything for the, okay, for consistency, let me make it easier because it's just gonna be time consuming. Okay, so we're gonna use T equals 0.2i. So Ti, wherever there is Ti, you put 0.2i. So that it's easier. So Ti is 0.2i in the previous formula. And it's the same thing. We can live in terms of I, but now this is going to be easier because that is what also is easily available from my computational device. So that's going to be exactly minus 0.008. 0.008, and then you have 8 here, 5. And then you have 6. We have I squared minus 0.00856. 0.00856, then I plus 0.2186 for each. Okay, so yeah, this one is what allowed us to just have the I here. We would have kept the TI, and then we were having T squared, but yeah, there's just that difference. If this is true for each, right? So for each, now the I runs from 1 up to big N minus 1. So in other words, N is 10, so the I's would be 0, 1, up to 10 minus 1, which is 9, okay? So let us do this now. Let us do this. For this particular question, okay. Now, remember that there's W0, which is alpha, but alpha is 0.5 in this question. And then, obviously, this is the same as, right, so is the same as the following. Let me just get my pen. Okay, never mind. Sometimes it drags. So now this is the same as what? Same as the initial condition for this problem, which is y0 is 0.5. Y0 is 0.5. So we know that y0 is 0.5. Okay, so that is the same, but it's the same as w0 equals alpha. Okay, and using the W notation is popular in the prescribed textbook. And so now what then we're going to use to get the next thing? So W0 is there. So we need to get W1 from this. So which means that we can get W1, but W1 estimates 0.2 because H is 0.2, right? So W1 estimates here 0.2, which is W1. Because W1, when I is 0, what are you going to have? You're going to have 1.2214 W0 minus 0.008856. Okay, but obviously, we're dealing with W1, so which means I is 0, so you can do 0 squared here. Minus 0.00856, then you have times 0 plus 0.2186, like so. Okay, now this is 0, that is 0, and then you're left with the last one. But it is 1.2214. The W0 is 0.5 for this question. That is the initial value. 0, 0, and then this one is 0.2186. Okay, we multiply by 0.5 and add to that. And that gives us what? It gives us 0.8293. Okay, but this estimates 0.2 and is approximately, okay, now my pen is dragging. Don't mind that. Okay, so it estimates exactly that. And what does it give? It gives us, just 1 second, I need to remove this drag. Right, so, okay, so that is 0.2 that gives us that. Okay, so we have, yeah, that's 0.2. So yeah, I was saying 0.2 is approximately W1, which is equal to this. So we got W1. W1 is like T1. It evaluates at T1. T1 is when I is 1 and we have 0.2. And then now we need W2. W2, we can easily do it even here. Let me do it in yellow because I'm just going to try to squeeze it here. So now W2 is 0.4. Okay. Right. So we're here now. Just 1 sec. Need to clean this up. All right. So I was saying we're doing W 0.4. Okay. So which means that 0.4 is W2. Okay. So if it's W2, then what do you achieve? Okay. So we're dealing with W2. W2 is going to be this is going to be W1, which is 1.2214. W1, you already have it. 0.8293. Okay, but it's W1, meaning at W2, the I is 1. Right. So if the I is 1, right, I remember there was a typo in my previous discussion because even the textbook was wrong here. I realized, okay, because the I only takes integers, but sometimes if in the prescribed book made mistakes and put like some 0.2 there, it can't be because the i's are integers. Okay, so please, I'm mentioning that because in my previous discussion, I realized that the textbook made an error in most of the calculations. Right, so which is 0.0856, then it's 1 because W2 is going to be W1 and is 1, 1. Right, so because the prescribed book that is used is by Richard Burden, numerical analysis. Right, so they made a couple of errors when it comes to the actual I values here. But you see, the results were correct, so I suspect the typist made a mistake when they were typing this. Right, so you have that W2 would have 1, because for this to be 2 is 1 plus 1, so which means I is 1 and it's 1 everywhere. And if you use the calculator, then what you're getting is 1.214091. And this is y of 0.4, and this is approximately W2. 2. Okay, so this is just something to sort of consider and to make sure that one understands this. So is W2. Okay, right. With that said, how far are we to actually now this order 4 thing has brought us the Taylor polynomial and has given us a difference equation that is different from the second order. But obviously, we need to continue and get the results. And I'm going to highlight this and get the results that are required. Okay, let's do just one more. Okay, because we must do this up to T. Right, so yeah, I'm just going to highlight this. So we draw a table. And this table, yeah, okay, never mind. I want to say it's a table, but this table is going to have the values of the Taylor. Right, I want to do white. So it's going to do Taylor order 4. Right, Taylor order 4. Right, if it's Taylor order 4, then we're going to have a couple of these. Let's do Ti. Then we're going to do Wi. Okay, if one wishes, you can call this Yi, like we're calling it Yi previously in the memos, right? So the Ti is going to be 0.0, but it's put some division, and then it's going to be 0.2, And then you add another one, 0.2 is 0.4. And then another one, 0.6, 0.8, 1.0, 1.2. Okay, I'm going to do the table here as well. So we can continue and write the TI. Okay, then we have 1.4, 1.6, 1.8, 2.0, like so. Okay, and then we can divide like this. Then we're going to have the WIs. What are the WIs? Okay, the WIs will become, for example, at 0, 0, we saw that the textbook said W0 is 0.5, the initial value. Okay. And then 2, 4, 5. Okay, W2, we got this one. It's going to be a W1. We got it. W1 is 0.8293. W1 is 0.8293. Okay, W2, 1.214091. 1.214091. Then we have this one here at 0.6. Right, so obviously we did not do W3. Let's just, I'm going to squeeze some of this here. Okay, let's just do W3 then, just to create the understanding. First, let's just write down the formula. So the WI plus 1, we know that a difference equation, we've already worked it out. And it is 1.2214 WI minus 0.008856, then I squared minus 0.00856I plus 0.2186. Okay, right, let's do W, okay, because this is W2, then we're gonna do, this is W0, W1, W2, then we do W3. So W3 is gonna have W2 here, which is 1.2214, and W2 is this one here, which is 1.214091 minus, okay, because it's W3, then it's gonna have 2 here. So it's 0.008856, then it's going to be 2 squared. And then it's going to be minus 0.00856 times 2 plus 0.2186. Okay, if you use a calculator, W3. Okay, okay, calculator will give us 8947. Okay, 648947. Okay, so we proceed with this. Know that one can't bore you a lot. Okay, so W4 is this one, 2.127. Right, 27, then 240. Okay, so that's what we put here. 2.127240. Then we have 2.640,874. 3 point. Okay, yeah, no, you can do these. So I'm just completing the table so that you can know how the table should look like. Then we have 799, then 64. And then we shall do the error. I'm gonna include the error column as well. Okay, that's 1.2. Then there's WI. Right, 1.4 is 3.732432. 1.6 is 4.283529. 1.8 is 4.815238. 2.0 5.30. Goodness me. Okay. Then you have quads here. Quad fives. Like so. Right, so we continue. Okay. Then we include the error. Right. The error, which is exactly YTI minus WI. Right, and so 0. Okay, so this one is what we did last time. So we compare with the actual and the estimated. We find the difference and take the modulus of that. Okay, but yeah, I know for this question, we did not give the exact solution, but it's known. Right, so the error, I'm going to state it, in fact, the actual solution to the differential equation, and then we can compute the difference. So in this case, for example, the difference is going to be 245, 451, 245. So it's 2453. And then here is 2456. 24. So this is 2410. 24. So 2415. We have 24. 2423. Okay, let's. Okay, how do we get the error? We just find the difference between the actual and the estimated. The W's are giving the estimated, but now we can get the actual ones. How do you get the actual ones? By writing out the original and computing the values of the original, and then subtracting from the W's. Right. So there's something that we need to consider. So okay, let's look at obviously we shall continue with the error. The exact minus the approximated values. Okay, for example, at 1.4, 0.2432. Oh, 2445. 1.8. 2462. Okay. 2483. Okay, this is sort of the result we get, but as indicated that this is what the difference between the exact and that, and the exact minus the approximate value at each of the values of t, and obviously this is what you get for the Taylor waterfall approximation. And now let us do further calculations, for instance, and I'm going to discuss some exercises here. Right, so let's look at some exercises. So your calculator is going to get ready because I'm just going to do an exercise. Maybe that's a little bit intensive, and then we move to the modified Euler. Now, what are the exercises? I gave the exercises, but I'm just going to give them to you again now. Right. So if I give, it's okay if I say use Taylor. Okay. All right. The most popular is order 2 in the textbook, prescribed textbook. So by Richard Burden, Richard Douglas, and Annette. So now the use Taylor's method. Okay, they like order 2 exercises of order. Okay, but once a person can do order 2, you can even do order a million, but just idea. So Taylor's method of order 2. I'm going to give a couple of exercises and then we shall do just one or two. Just one, sure, will be enough to approximate the solution. To approximate the solutions for each of the following initial value problems. Okay, so A, y primed is equal to te to the 3t minus twice y. Okay, this is, I potentially have given, but I want to pick from them just one before we move to the next section. And so that you can practice with it. Y0 is 0. Okay, with h equals 0.5. Right, part B, we look at y primed, which equals 1 plus t minus I. And then you have 2, 3, y2 is 1 with h is 0.5, c, y primed is 1 plus y of t, 1, 2, 1, 2 with h 0.25, d, y primed is cosine 2t plus the sine of 3t, t1 between 0 and 1, and then y at 0 is 1 with H equals 0.25. Okay, now you have these problems. Okay, they are just repetitive in the textbook, but now if these are the exercises, let's just do the first one. Okay, let's just do the first one for simplicity. Right, if we do the first one, yes. Right, so shall we look at the solutions to this? Right, so we are going to do A. What is A? Right. What we just wrote, so it is y primed, which equals t e to the 3t. Just practicing this one, to y 0, 1, y at 0 is 0, with h equals 0.5. Okay, let's look at these carefully and analyze this and see how best we can solve this. All right, so obviously we're dealing with order 2. Right, Taylor's method of order 2. Okay, if the order is 2, we write the formula, right? Just writing the general formula. So which means we shall start by writing W0 is alpha, and then WI plus 1 is the same as WI plus HT to the power n. Okay, this is what we state, T to the power n. And then we have TI WI. Right. But this here is true for each I, which is 0, 1 until n minus 1. Okay, this is true where t nth derivative of ti wi, which is f ti wi plus h over 2 f primed ti wi. All right, so we add this one, and then we have h n minus 1, n factorial, and then n minus 1, and then ti wi. Okay, but we're looking at order 2. So order 2 means we're just going to be dealing with the t. Right, and then we shall just replace n by t here by 2. So if we replace n by 2, that means t2 of ti wi, which is f ti wi plus, okay, this is 2, which means we have out of 2, it's easier because 2 has fewer terms. Okay, obviously, if n is 2, then you can see 2 minus 1 is 1, so you're going to stop at 1. You're going to stop here. Right, meaning that when we continue, we're going to have T2. Okay, we're doing this textbook exercise. And then it is exactly F Ti Wi plus, then we have H over 2, then we have F primed over Ti Wi, like so. Okay, now it remains to just get the difference equation for associated with the Taylor and this problem. But first, we need to look at the question in the exercise. So it says y primed is equal to this. So it's giving us y primed. So it's giving us f of ty. So f of t and y. So which means that f, goodness me, of t and y are and W. Okay, so yeah. Okay, you can write like that, just to the standard notation. So, but first things first, we just write f of, and then this one, we just use the yt in the beginning. Question of choice of symbols. Right, so we use yt like this, but then we shall, the y becomes the wi, okay? So, which means this is y primed, and the y primed is exactly te to the 3t minus 2y. Right. But then we just need also the f primed. So we must find a derivative of this. Okay, we must find the derivative of that. So which means that now we shall need also f primed, which is d dt of f. Okay. So yeah, te to the 3t minus 2y. We find the derivative of this one. What is the derivative of this? Product rule, because it's a product of functions of t. So the derivative of t is 1 times e to the 3t plus t times the derivative of the exponential becomes 3e to the 3t minus 2y primed. Right. That is exactly e to the 3t plus t e to the 3t. And then this one is sort of what is required. Okay, so this is f primed of t, y of t. So what do we get out of this? What do we get out of this? Okay, we substitute everything. Right, so we remember, therefore, that T2 of TI is the same as F of TI plus H of 2 F primed of TI, which means T of 2 is TI. Okay, what is F of TI? Okay, so we've already got, it's this one here. It is exactly, so the T is replaced by TI e to the 3TI minus 2. The Y is replaced by WI plus, then you have H over 2 into the F primed is this one, which is E to the 3TI plus TI e to the 3TI minus 2. Okay, we need to just do something extra. Okay, we need to do something extra. We need to replace the y prime to that. Okay, right. Now to replace the y prime like we saw before, this is exactly e to the 3t plus t e to the 3t minus twice this, which is exactly t e to the 3t minus 2y. And so what are we getting here? So this one is minus 2. Okay, so it is e to the 3t. Right, so t e to the 3t minus 2 of that is minus t e to the 3t plus 4y. Plus 4y. Right. So that is what we get. Okay. Now we come here. We substitute. Okay, now we come and we have h over 2 into the f primed. So f primed is just this. So we come and we substitute there. So I need to clean this up. Okay, we have this, so yeah. And then now We're going to do it in white and say it is e to the 3ti minus ti e to the 3ti plus 4wi. Okay, just need to clean this up. My pen was dragging. So yeah, the pen was dragging a little bit. So okay, just gonna make these wi like this. Okay, so it's exactly what we're getting here. Right. Now, moving forward, we shall be in a position to have T I W I equals. Right. Equals Ti e to the 3Ti, which is the Ti e to the 3Ti, like so, minus 2Wi. Minus 2Wi plus h over 2. Right, which is plus h over 2 into, okay, then we have e to the 3ti. We have e to the 3ti minus ti e to the 3ti minus ti e to the 3ti, okay, plus 4wi. Plus 4wi, like so. And then now we have this, and we just need to group like terms together and so on and so forth. Like we did previously for the fourth order. So this one is the second order. It has fewer terms. It must be easier. Okay, so now we can start with anything, literally. Just this one is minus 2wi, but if you multiply by the h here, this one is going to be 2h. So which means that when it comes to the wi, we shall have only two of them. So it's going to become 2h minus 2. Okay, for a start, wi, like this. And then, what else are we going to have? Then we're going to have the ti's, the ti's e. Ti's e. There are two of them. So which means that we shall have the two of the ti's. So you can write, so it's going to be exactly 1 minus h over 2 ti e to the 3ti, like this. Okay. Okay. Right. So yeah, we're done with the ti's. And then now we have the e only. It's going to be only h over 2 e to the 3ti, like this. All right. Okay, let's continue. Let's continue. Let's continue. Okay. We need to just cross-check if this is exactly the same as this and we did not make any mistakes. Okay, let's just see. So this will be 2hwi, which is going to be 2hwi, okay? And this is going to be minus 2wi. So wi's are taken care of. Then here you're going to have the tie, okay, to the 3. And then this one is going to be minus h over 2 tie. And then there's going to be h over 2, yeah, okay? Looks very correct. So yeah, we got that one. Hence, we know that the wi plus 1 for the advanced Taylor or for the higher order Taylor polynomials, all right, it becomes this plus. Okay, I need to clean up here. So it becomes wi plus ht. In this case, the second order, so it's tiwi. Right, so Wi plus 1, sorry. It's exactly Wi plus H. So now we plug this in. Minus this Wi plus 1 minus H over 2 Ti e to the 3 Ti plus H over 2 e to the 3 Ti. Like this. Okay. Now, what is H here in this question? We must substitute the H. So if you look at the question, the examiner is saying that, or the author of the book is saying, why prime does this? T lies between, oh, they've given the H. Either they give the H or they give N. It's 10, and then you can divide the difference here by 10 but now they've given H. So clearly H is 0.5, so we just use it. So, which means that now H here is 0.5. Which means we shall have Wi plus 1, which is Wi plus, you put a 0.5 in the place of H to get the difference equation, and then we will just use it. 0.5 minus 2 Wi plus 1 minus 0.5 out of 2. Oops. Okay, that's fine. I'm just going to clean this up. Right. Okay. Right, so we're replacing H by what? By 0.5 in the question, as stated in the question. So in the place of the H here, you put 0.5, then divide by 2. Then you have Ti e to the 3 Ti. And then here you have 0.5. Oh, okay, sometimes the pen drags. You forgive me then. Right, so in each case, therefore, I'm just going to clean this up and just continue quickly. I want us to just get these done. So you have 0.5 out of 2. Okay, like that. And then you have e to the 3 Ti, and then we close. All right, so we just need to simplify it. Let's see if we can just try to simplify it here before we move to the next slide. So let's see now, what do we get here? Okay, this one, 2 times 1.5 is 1. 1 minus 2 is minus 1. Right? Okay. So we have minus 1. So, and this is minus Wi times 0.5. It's minus 0.5 Wi. So Wi minus 0.5 Wi is 0.5 Wi. So we're getting a difference equation here. Okay, so 0.5 Wi. 0.5 Wi, like so. Okay, so the Wi is done. Then now we focus on the Ti, okay? So now here you have 0.5 divided by 2, which means it is 0.25. Right, so 0.25, we deal with it. 1 minus 0.25 is 0.75. Okay, so 0.75 times 0.5. Okay, so 0.75. Now, yeah, 0.75 times 0.5. Right, so it's 0.75. Right, so you have, okay, let's just do that. Right. Okay, just we're just doing this here. Okay, I'm also using my the calculator to show you the one on the screen, but it's 1 minus 0.5 divided by 2 times, okay, 0.5. 0.35 it appears. Okay, so this one is going to be 0.35. which means you have 0.375 ti e to the 3 ti. Okay, so now, which means I have 1 minus 0.5 divided by 2. Okay, I'm just confirming the things, please, so that we write correct things here. Right, and then you have times 0.5. Okay. Right, just verifying quickly. All right, so you have 0.5 and then you have 2 there. Right, that's correct, 0.375. All right, and then that is right. Okay, so this one is 0.5 times 0.5 divided by 2. Okay, let's just do it. Right, so we also have 0.5 times 0.5 divided by 2, like so. Okay. 0.5 times 0.5 divided by 2, 0.5, yeah, because this is 0.5 times 0.5 divided by 2 is actually 0.125 e to the 3 ti. Okay, so which means that you have wi plus 1, which is the same as what? 0.5 wi plus 0.375 ti e to the 3 ti. And then you have plus 0.12. 125 e to the 3 ti, like this. Okay. Okay, but also we know that W0 is alpha. For this question, let's just write the answer. We've already got the difference equation. So we know that Y0 is 0. Okay, so that's what we're going to use. Y0 is 0 means that W0 is 0. Right. So we got W0. The next thing we shall get is W1. Okay, what does W1 approximate? So maybe that is what we need to emphasize sometimes at each step so that we do not go past what is required. Because now, if you look at the next thing, W1 approximated the next step of this. So this is W0 at T0, then T1 is when you add 0.5. So you add 0.5. It approximates W1. And W1, according to this, is 0.5. W0, there are 375 T0. Okay. E to the 3 T0. 0.125 e to the 3 T0. Okay, it's T0 because now I is 0 here and we want to W1. Okay, let's just plug in everything. So this is 0.5 W0 and then 0.375 T0. It's the beginning one. T0 is 0 from here. So it is 0 e to the 3 0. plus 0.125 e to the 30. Okay, tomorrow we shall spend some time on the textbook, on the exam of last year, November. We have built some momentum over these past few meetings. So this one is 0, this one is 0, and then we're just left with this one. But this is like e to the 0, which is 1. So we're just left with 0.125. Okay, it approximates that. And then now, and then this function, this t is from what to what is this? Very nice question, very nice and short. Because t, we need to stop at 1. So we'll stop at the next step. Right, because it's between 0 and 1. Now, and then we're going to do the next one. So we're going to estimate W2, but W2 is at what? At T2, because T0 is this one. T1 is when we add the H, 0.5. T2, you add H, you get 1.0. Okay, yeah, T3, we don't go through it because it's between 0 and 1, so we don't proceed. We would go up to 1.5, etc., higher, but yeah, there's no need because our T is exactly between 0 and 1. So we're gonna have here this one at 1.0, which is approximate to W2. And now W2 therefore is the same as what? Is the same as 0.5 W1. Okay. Plus 0.375. Okay, because it's W2, then I is 1 here. So this one, for instance, is T1 e to the 3 T1 plus 0.125. Okay, we're just doing this so that we're just familiar with the methods here. And then now it's 0.5. Okay, and then what is W1? We've already got it, is that one is 0.125 plus 0.375. What is T1? It's 0.5. So here you put 0.5 e to the 3 into 0.5 plus 0.125 e to the 3 of T. Okay, this is T1, not just I, so which is 0.5 here. Okay, we just need to do this quickly and get the answer. Right, let me just do this one and see what it is. Okay, so what we have is 0.5 times 0.125 plus 0.375 times 0.5 times e to the power 3 times 0.5. Okay, and then now what do we get here? We get plus 0.125 times e to the power 3 times 0.5. So, okay, so this one is the same as 1.46. 1.46302, like so. And this is 1.0 is approximately W2. Right, so with that said, then we got the estimate. So because now the question was, so in other words, hence, W of 1.0 is approximately W2, which is what we just got. 1.46302. Okay, now let's look at this carefully and think of this. Okay, now, these ones have already been solved, and need to make comparisons. Right, okay, I'm just returning now. Think the solutions we found to this in terms of the exact solutions to this. Okay, they did not write the exact solutions to this. All right, but that is what we get. Now, because we're sort of familiar with the Taylor method, I want us to continue and look at other advanced methods of interest that we need to focus on. For example, I want us to look at the midpoint method. Right, so there's another method we call the midpoint. Okay, so we shall use this in our revision tomorrow. Right, let's look at the midpoint method. And then we shall look at what came in the exam in November, the modified Euler as well. Okay, did Euler last time. Euler is Taylor of order 1. Okay, we saw that. So what does the midpoint method say? It says that the formula for the midpoint says we have an initial value, W0 is alpha 0, is alpha only. And then Wi plus 1 is exactly Wi plus hf into T sub I plus h over 2 Wi plus h over 2 f of Ti Wi for I0, 1, and so on. So now we need also, this is the midpoint. Okay, we're going to use it, but this is the formula for the midpoint method. Right, but now there's another method I want us to speak about. That came in the exam, modified Euler. The modified Euler. Okay, we spoke about Euler, which is just Taylor of order 1. But now this one is the modified Euler. And what is the formula for the modified Euler method? Right, so the modified Euler method is what? The modified Euler method means this, which means Wi plus 1 is the same as Wi plus h over 2 plus h over 2 into f of Ti Wi plus f of Ti plus 1. Then here you have Wi plus h of f into Ti Wi for I equals 0, 1, and minus 1. Okay, so here are the two methods. I want us to think of these very carefully and make sure that we understand these methods. Okay, this is the midpoint method, and this is the modified Euler, right, which is W0 alpha Wi plus 1. The modified Euler came in the exam, so it is actually Wi plus h over 2 into f of Ti Wi plus f of Ti plus 1, comma, Wi plus hf of Ti Wi. Okay, so these are the two methods, the midpoint method and okay. You note that in the midpoint method, what we do is we divide h by 2 within the parentheses of the f function up there. Okay, but let's look at an example here that uses this as we shall use this in the past exam question of November. But now let's look at an example. How do we solve problems that require the modified Euler and the midpoint methods simultaneously? Right, so let's look at this example. Highlights the significance of the methods, like you'll see just now. This example says use the midpoint method. Okay, the midpoint is not popular in the exams, but the modified, yes. And the modified, we saw it in November, this one. The modified Euler method with n equals 10. H equals 0.2. Ti 0.2i. And W0 equals 0.5. To approximate the solution to our usual example. Okay, so we just are going to do the one we studied before, and we studied y primed equals y minus t squared. It doesn't really matter, but we just want to illustrate the methods here. But this one is one example we studied before using a different method, but now we're using the midpoint and the modified Euler. We studied this. Right, and then we have 0, y of 0 is 0.5. Goodness me, like this. Okay, let's see what we get. Let's see what we get here. Solution. Right, so we have the solution. Okay, to look at the solution to this, we are gonna first find the difference equations of each one. Like first, let's spend a few minutes on the midpoint. We just need the difference equation for each one. And then once we get the difference equations, then we can complete the tables. The question becomes, what are the difference equations for each of the methods? Like for the midpoint, this is exactly what we have there. But what is the difference equation? So we start with the midpoint. Okay, once you get difference equation, we can complete the table. So now this is the initial value. And then we have Wi plus 1 is Wi plus hf into Ti plus h over 2. Okay. So we have, okay, just a sec. Something got pressed there. Right, so you have that, and then you have h over 2. Okay. Wi plus h over 2. F of Ti Wi. For I equals 0, 1 up to n minus 1. Okay, with this said, then we're going to proceed to find difference equation that is required. Y primed is f of t y of t, and it is a y minus t squared plus 1 between 0 and 2, and then we have y of 0 is 0.5. Okay, with that said, we know that wi plus 1, the previous screen, is wi plus hf into ti plus h over 2 wi plus h over 2 f of ti wi, like this. Okay. We have, this one is like the Euler, but we just have h over 2 here. So which means that we can just quickly move to the answer, and which means wi plus 1 for the difference equation is wi plus h. Right, so the f now, we just need to get the f. So the f is exactly what we have there, is exactly the f given, but it means therefore what we're going to do is that we're going to add h over 2 to the ti. Right, which means therefore we're going to have h and 2. If this is f, right, wherever there is wi, what do we add to wi? We add h over 2. So which means we're going to, the y, we're going to write it as wi, and then we have h over 2. Then we put this. Right, so we put f of tiwi. So f of tiwi, it's going to become, this one here is going to be wi minus ti squared plus 1. Okay, so this is for the wi part. We add this. Right, and then now, but we have this f function, but wherever there is ti, we're going to add h over 2. So we have this one. Wherever there is ti, we're going to add h over 2, and then we square this. Right, h over 2, and then we square that, like so. And then now we're going to have this, and we add the constant, like so. And this is the midpoint method. Okay, right. So after we have written this difference equation, as usual, we try to simplify it for us to be able to complete the table with ease and to find the rest of the approximations. But we know that h is 0.2, so we can just substitute that one. So that wi plus 1 is wi plus 0.2 into, you have wi plus h is 0.2 out of 2, and then you have wi minus, okay, can leave it as ti, but you can change it. Okay, it's easier as ti, but you can change it. All right, okay, I'm going to change it for convenience. So we know that as usual, so from h you can get ti to be 0.2i. So that wherever there is t, then you put the 0.2i. Okay, it's popular to do things that way in the course, in the prescribed textbook. So to make sure that we just maintain uniformity, okay, we have that. So what do we have? So which means that here we're going to have 0.2 I squared plus 1 minus 0.2 I plus the H is 0.2 out of 2. You square these plus 1, like so. And then you close, okay? This is exactly, so we just replaced H by 0.2 and the Ti by 0.2 I to get the difference equation. So now the midpoint method. Midpoint method. Okay, we're dealing with two methods here, both the midpoint and the what? And the modified Euler, which is Wi plus 1 is the same as, so it's 1 point. Okay, because now you just look at the Wi, like we have here. This one is Wi. You divide by 2, 0.2 divided by 2 is 0.1. Okay, but you must multiply. Is 0.1 plus 1, which is 1.1 Wi. 1.1 Wi times 0.2. Right, so you have 1.1 times 0.2, 0.22, 1.22. So this is 1.22 Wi. Okay, now we just have then the i's, you add everything, it becomes 0.0088 I squared. Okay, you might decide not to use the I and just leave everything as Ti, like normally in the memos, it's common they do things that way, but the answer will be the same in the end. So 0.00. Okay, the methods I'm using here are recommended in the prescribed textbook, and so that's the reason why I'm trying to make sure that we familiarize ourselves with the methods in the textbook, because the formulas are explicitly stated. The memos, old memos, sometimes do not state the formulas explicitly, making things unclear. Okay, right. So the next thing here we're going to do is to do the modified Euler. Right, next we do the modified Euler that came in November. How does the modified Euler differ from the Euler? Okay, we know that W0 is alpha, and we know that in the modified Euler, Wi plus 1 is Wi plus H over 2 into FTI Wi. Okay, I just got difference equation of the midpoint, and then I'm going to get the difference. We're going to get the difference equation of the modified Euler, and then we shall use this to approximate the solutions. So now we have this one, this is the modified Euler, which is Ti plus 1, comma, Wi plus HF of Ti Wi. Okay, this is true for the i's. The I is 0, 1 up to n minus 1. Okay, now this is the case, but what do we do with this? Right, so we just need to remember what the f function is, okay? We don't need even higher order things here, like Taylor. So we remember that f of t, y of t is y primed. For this question, it is y minus t squared plus 1. Okay, so we have Wi plus 1 equals, okay, I'm just substituting into this, using everything there. So which means it's wi plus h over 2. Now we have f of ti wi from this. So which means the y becomes the wi, the t becomes a ti squared plus 1, plus then we come to this one. Right, so for this one, we use the same function, but we know that t becomes ti plus 1. So, which means here, for example, in the y, what does y become? Y become this. Okay, y become this. Okay, so what, okay, y, this one. Y becomes wi, this y. So it becomes wi plus h. This is the y. H into this. What is FTIWI? FTIWI is this. So it's exactly this up to 1 here. So we're just going to put WI minus TI squared plus 1. Okay, that is H. Like that. So if Y becomes this component, and then we close like this. Okay, and then after we close for the Y, and then there's minus t squared. What does t become? T becomes ti plus 1. So it's going to be ti plus 1, which is square. Right? And then plus 1. And then you close. So it's exactly what we have there. Right, it's exactly what we have. And then now we just need to substitute everything. It's just to play around with this. Modified Euler. Right, so it's wi, and then h is 0.2 for this question. You divide by 2. And then we have wi. Okay, so it's wi minus ti squared. Minus ti squared plus 1 plus, okay, like we do before, and like we always do. Okay, it's common in this course. H is 0.2. Use a decimal point, then a comma. Okay, our education system in school emphasizes the use of a comma, but university is more international, and at university we use a decimal point because that is what the American system and the British use. So now, okay, we have h is this, but ti therefore becomes the 0.2, then you multiply by I, meaning here we're going to use the, wherever there is ti, doesn't matter, but yeah, we're going to use exactly these. I just want the things to be very common with what is in the standard prescribed textbook. So which means here, so that it can be easier for us. So ti is going to be 0.2i, and then you square it, plus 1 plus wi, bring down the wi, and then the h is 0.2, and then we have wi minus, okay, the ti is this one, which is 0.2i, and then we square it, plus 1. Okay, I know that this is just one of the, okay, it's just one problem on the modified Euler. Okay, right, and then we have minus the ti plus 1. So ti plus 1 is going to be 0.2, and the I is going to be plus 1, which means that at this point it's going to become 0.2 into I plus 1, and then you square this. You square this plus 1, like so. Right. Okay, for the modified Euler, what do we have? Okay, so, okay, now we come here. The W occurs here, W occurs here, and there are like 3 of them. So this is 0.2 WI. And then there's WI, which is 2 of the WI, which is 2.2 WI. Okay, so you have 2.2 WI plus this one is 0.1 times 2.2 plus 1. Okay, so it's 1.22 of the WI. Okay, so we took care of the WI, and then we have minus 0.0088 I squared. Okay, we're going to square the I here and have I squared. And then because of this one here, I plus 1 squared, you're going to have something. Okay, so if you square these, it's going to be I squared plus 2I times 2, which is 0.2 times 2. 0.2 times 2 times 0.1. 0.2 times 2 times 0.1. Okay, let's see. Just checking this one. Yeah, it's gonna, okay. Okay, there's a square. So it's gonna be 0.04. If you square 0.2, you have a 0.04 times 2. Okay. Times 0.1. So this one is going to become minus 0.008I. You can always check that if you expand everything there. And then this one is going to become 0.216. Or the modified Euler is going to give us this. That is the difference equation for the modified Euler. And this is the case for each. I equals this. Okay. Let us complete the table. Let's complete the table. For the modified Euler first. How does the table look like? Because that's what it will be done in the November exam. We know first that W0 is alpha. For this problem, we know that Y at 0 is 0.5, meaning that this is exactly 0.5. Okay. Right. So we continue. We continue. Okay, okay, sorry. We're here. Okay, right. So we got this one. So WI plus 1 is 1.22 Wi minus 0.0088 I squared minus 0.008 I plus 0.216. Okay, so we're going to get W1 from this. Okay, so I0, W0 minus. Okay, so we start with when I is 0, so it's W0, and then this is 0, which is 0.00 880 squared minus 0.0080 plus 0.216. Okay, so this is W1 1.22, 1.22, and then W0 we already know is 0.5. 0.5 minus 0.0088, 0 squared minus 0.008 times 0 plus 0.216. Okay. And if you do this one using a calculator, it is 0.826. 0.826. Okay, then let's do W2 for the modified Euler. Okay, so W2 is obtained when I is 1 here, which is 1.22 W1 minus 0.0088. Okay, so W2 then is going to have a 1. So it's going to be like 1 squared minus 0.0081 plus 0.216. Okay, but we agree that W2 then has 1.22. W1 is 826 minus 0.0088 times 1 squared minus 0.008 times 1 plus 0.216, which means you have W2. Okay, for the modified Euler. So if you use a calculator for all these things, what we're getting here is 1.20692. All right, so obviously this is what we've done for the modified Euler, and then we need to do the same for the midpoint. I started with the modified Euler. It's quite an interesting one because we're going to be looking at that, looking at the exam of last year. And then of November, yeah. Okay, last year. Right, so obviously now we're going to be looking at the midpoint as well. The difference equation and just getting up to W2, and then we shall extrapolate for the rest of the values, like for the midpoint. For the midpoint method, okay, we know that W0 is alpha, but we've already found the difference equation, which is Wi plus 1, which is 1.22 Wi minus 0.0088 I squared minus 0.008 I plus 0.216. 0.218, like so. Okay, right. Now let's get some of the values. Like, you already know some of the things. Okay, so which means that here we know that W0 is 0.5. Okay. Which means W0 is 0.5. And then you have W1, 1.22 W0. Okay, when I is 0, minus 0.0088. Okay, when I is 0, so this is 0 squared, 0.0080 plus 0.218. Okay, when I is 0, you have W1, which means 1.22, 0.5 minus 0.0088, squared minus 0.00. Okay, all right. I lost contact. Right, I'll see you tomorrow. All right. I'll see you tomorrow.